Hello and welcome to Pmos and depletion mode devices video tutorial. This tutorial describes the models used for Pmos and depletion mode devices in PSpice. Let's open a new PSpice project and build a circuit shown. We will be using mBreak P3 model for MOSFET from the breakout library. So please be sure to have your breakout library selected. Note that the top terminal of our device is the source of the MOSFET, which means we have to mirror our object vertically. Let's also select a V-sign voltage source because we'll be doing transient analysis. Now let's wire our objects. Now let's go ahead and edit our PSpice model for the MOSFET. We have the same parameters, threshold voltage, Kp, width, and length, and note that the threshold voltage here is -2, Kp equals to 40 micro, width is 377 micro, and length is 1 micro. Let's go ahead and save and close. Now let's put our offset voltage for our voltage source to be 0. The amplitude will be 100 or 0.1, and the frequency is 1000 Hertz. Now note that we have biasing voltage source of 20 volts. Our R1 resistor is 4K, R2 is 135K, R3 resistor is 79.4K, our capacitor is 1 microfarad, and our source resistor is 4K. Now let's go and create new simulation profile. Our runtime will be 10 milliseconds, so we get 10 cycles. Maximum step size is 0.01 milliseconds, and please don't forget to click on the output file options and select include detailed bias point information. Let's hit apply and OK. Now let's put our voltage probe and run our PSpice simulation. Alright, let's go ahead and confirm our operating point. Go to output file. And take a look at our Q point. Let's close the window, and right now we will go ahead and see that our wave doesn't have it has a DC offset just because we don't have an output capacitor. So let's measure the peak and the highest and the lowest values and figure out our gain. So to do that, we hit a toggle cursor and we hit the peak value and we mark this value. Now we're going to hit the low value, and again we will mark this value. So let's uncheck toggles cursor and separate our values, and you can see that the maximum is approximately 10.073 and the minimum is 9.893. So this means that the output is 100 millivolts peak to peak or 90 millivolts peak, and since our input was 100 millivolts peak, this amplifier has a gain of 0.9. Okay, now let's go to the second part of our tutorial, and in this section we'll use the NMOS depletion mode device. Let's open a new project and create the circuit shown. And for our MOSFET model, we will use MBreakN3D, where D stands for depletion mode device. And again, we'll use breakout library. Okay, let's wire our parts. And our bias voltages will be 5 volts and negative 5 volts. Our one resistor will be 800 ohms. Our two resistor will be 600 ohms. R3 14.5 K and R4 5.5 K. Now let's go ahead and edit our PSpice model. We will have the same parameters, and our VTO will be, the threshold voltage will be in this case -1 volt. Our KP will be 0.1 milli. Our width is 10 micro and length will be 1 micro. Let's save and close the window. Now let's go ahead and create a new simulation profile. Here we will do just a bias point analysis, so we'll just select the bias point, and we don't forget to include the detailed bias point information. Apply and OK. Let's run the simulation. And when the simulation is complete, we go to View and Output File, and we can scroll all the way down to our operating point values, and we can just confirm our operating point values. This concludes our tutorial on PMOS and depletion mode devices. Thank you for your attention.